Good evening, students. Welcome back for the topic of work and energy. Last time, students, we have told you what is work. What is work? So, we told you you are doing work every day, but in physics, our work is force into distance. And we told you there are two conditions for work to be done. What are the two conditions, students, for the work? What are the two conditions for the work? Tell me, last time I told you that if you have to do work, student, if we have to do work, then there are two conditions for the work. What is that? There has to be a force, must be applied, and displacement has to be there. The body will displaced is moved from its position, student. So we define work is equal to force into distance, students. And various type of works we told you: positive work, negative work, zero work. Can you give me an example of zero work, student? What is a zero work? Zero work is done if the force is acting perpendicular at right angles to the direction of displacement. This is the direction of displacement, students, and the force is applied at perpendicular to this. Then what we said, this becomes Fs cos 90. I have given you an angle. Then W is Fs cos 90, which is equal to cos 90 is 0. So Fs into 0. So the work becomes 0. So if you are standing and putting a box on your head, student, what happens? The box is on your head. There is no displacement if you are moving. If you are moving, the box is not moving. So work is not done on the box. So these are some of the important points we told you, students. Clear? Any doubt here? Tell me. We have made
No,
some.
sir, no
Okay.
doubt.
And we told you that if we know the value of the force or displacement, we can calculate. Then what was the SI unit of work, student? What are the SI units of work, students? What are the SI units of work? Tell me, what are the SI units of work, students? What are the SI units? What is your answer, students?
Sir, Joule.
Yes, Joule is the correct answer. Your answer is correct, joules. Now, student, the second part of the topic is the energy, student. Energy. What is energy, student? You are saying, sir, I have energy. If I don't have energy, can I teach you, student? The answer is no. Can I walk without energy? No. So, any work I do, student, any work I do, I need energy. Any work you will do, you will need energy. You need energy to do any work, students. You can walk, you can do bicycling, and you are doing some work, student. You are doing some work, but you will need energy, students, to do the work. Yes or no? So, what we are saying, without energy, no work can be done. Tell me, can we do the work without energy, students? Can we do the work without energy?
No, sir.
Okay. And is your life possible without energy? What is your life, student? You are eating food. You eat food every day, and you are saying food provides you energy. Food gives you energy. Energy, you are talking of, student, calories or joules of energy. This energy is being produced inside your body, students. And then what you do in your life, student, we are able to work. You are doing work. What type of work you are doing? You are running, you are walking, you are moving up and down. So you are doing work, student. So work cannot be done without energy. So energy has to be there to do the work. If you want more work to be done, student, you will need less energy or more energy. Tell me. If you want more work, if you want to do more work, student, you will need less energy or more energy. More energy. You are running, students, posing. You are running 1 kilometer. Another is running 2 kilometer. Another one is running 5 kilometer, student. Tell me, you will need the same amount of energy. The answer is no. You will need more energy if you want to do more work. More work is done, more energy. Less work is done, less energy. Tell me, right or wrong? Yes, tell me. What do
Yes,
you?
sir.
And you know where the our life energy, where which is the most important source of energy for all of us. Tell me, our life process works on energy. Every particle of your body needs energy, student. Every particle, I am saying, you are made up of very, very tiny particles. You are made up of very, very tiny atoms, molecules, students, very, very tiny particles. And each of your body cells needs energy. If your cells don't have energy, they will die. Where the energy is coming from? The food, the fuel which you are adding to the body, student, they are giving energy to your cells. And when the cells get energy, they work, student. Yes or no? In other words, student, you can say the what is the simplest definition of energy is the ability to do the work. I'm saying energy is the ability to do the work. How much work, less energy, less work, more energy, I can do more work. Anything which is working will need energy. Can a machine do work without energy? Tell me how your machines are running at home. Any machine you are running, student, you are giving energy to that machine, yes or no? Tell me. Are you doing mixie, grinders, anything, your washing machines, TV, everything which is working, student, at home? It needs energy. Energy is required to do the work. That is what we are saying. Energy is how things change and move. It is everywhere around us and takes all sorts of forms. You are cooking, you need energy to cook. Can you cook your food without heating? Answer no. You are going to school from home, you are driving, student, then again energy is required. You want to jump, you want to run, any activity you are doing, walking. So, but there are different forms of the energies that we know, different forms of the energy. So, can you tell me which is the biggest natural source of energy? Tell me, which is the biggest natural source of energy on earth? Tell me, what is your answer? What is your biggest natural source of energy, students? What is your answer, student? On earth, which is giving the biggest and natural source of energy? Any answer? You know it so well.
So, sun.
Yes, correct answer. Sun, sun is shining. Oh my God. And sun is giving you what, student? What the sun is giving you? You are saying heat, light, and other type of radiations are also there. Heat, light, electromagnetic radiation, students. And sun is the most important source. And important point, photosynthesis is taking place. You know what is photosynthesis, students? Plants are preparing their food, students. What they are using? Carbon dioxide, water. You are saying Carbon dioxide is there, water is there, students, and what is there? Sun, sunlight is there. Here, sunlight is falling. Then chlorophyll is there, and what is happening? C6H12O6. We are saying they are preparing their food, students. And what is being obtained in this process, student? Oxygen. They are releasing oxygen. So what is happening, students? That energy, sun is providing energy to many things. Plants and trees, you see, they need sun energy to grow. And they are further source of energy. They are further providing energy to us. So in our daily life, we are saying you are continuously aware of different types of the energy. In physics, I am saying the capacity for doing work, it can exist in different forms. Potential energy, kinetic energy, electrical, chemical, nuclear, various other forms of energies are known to us students. For example, you are aware of heat energy, chemical. What is the chemical energy, students? Energy stored in the chemical reactions. Your cells, battery, everything, you see what is it run on the chemical reactions are taking place. Chemical reactions take place, energy is produced, students, in the cells, in the batteries. You have seen small cells which you are using. They are providing you energy, student. There are energies stored inside the nucleus of the atom, student. The nucleus of the atom, which you are also talking of nuclear energy, student. Nuclear energy. Nuclear energy is that energy which is present, student, inside the nucleus. So this energy we are getting from the nuclei of the atoms. You know, every atom has a nucleus. Inside the nucleus, there are neutrons and protons. There is a strong energy inside the nucleus, student, which is being used in nuclear energy, atomic energy, nuclear energy. And electrical, you are so much aware of electrical energy is the most convenient form of energy because it can be easily transmitted from one point to another. So you are using electrical energy a lot, student. It travels easily from one place to another place. It reaches your home. Beside this, let us see some other sources of energy. What are the sources of energy, students, in general? What sources of energy you are aware of? You are talking of the nuclear energy, coal energy, wind energy, water energy, biomass, natural gas, oil, solar energy. So many types of energy you are using in everyday life. Are you using? Yes or no? Tell me. Are you using all these forms of energy? Various forms of energy, student? Renewable and non-renewable energy resources, you know, which can be renewable, and which will exhaust non-renewable. Here, for example, solar energy continuously. Biomass, the plants continue to grow. Student, wind energy, with wind, you are able to rotate these windmills. Windmills, you have seen geothermal energy, student, hydropower, water power. And non-renewable, oil will finish one day, coal will finish, nuclear, if the nucleus finished, natural gas, if your gas is finished, what will happen? Then it cannot be renewed. Where you are getting these natural gas, you are saying this is obtained from under the sea or under the earth. See what type of energies we are using in our everyday life, student. Hydro energy, Baghra Dam, you see how the water is falling from a bigger to a lower height, and then you are running, you see, and generating. Generators are there, you are generating electricity. Solar energy, you are using wind energy, you are using. Where are you using wind energy? Have you seen anything like this? Wind energy? Have you seen wind energy? That windmills, have you ever seen it? In our country, which part of windmills located? Where there are strong wind blows, students, the windmills will rotate and that energy can be used and converted into electrical energy. Tidal, as the tides of the water, geothermal biomass, as you are burning the biomass, you can produce energy. All these are different sources of energy. Yes or no? Are we aware of them? Tell me.
Yes, sir.
Now, why do you need energy? I said कि देखो energy is required to do the work. No work can be done if you don't have energy. And you are saying if there is a more energy, student, then more work can be done. You want to work more, then more energy will be there. You need more energy. So what is happening, student? In our everyday life, you have you have a hammer and you hit this with a hammer, student, hammer. What happens? You are doing work, student, when you are hitting this, okay? Then energy is required to do this work. Energy is required to do the work, student. An object is at a higher height. This is at a higher height, at height h. It falls to a lower height. Student, what happens, students, when an object is at a higher height? You are saying it has acquired some energy. It has acquired energy because it is at a higher height. As soon as it falls, student, what will happen? You will see it will, if this is a ball, it will start moving ball. It has energy, student. It has more energy than the energy which it was having at the ground state. It has gone to height. So there is energy present when you have moved a body from ground to a higher height, student. So what is the story? This energy, we can say, objects acquire through different means. ठीक है? Energy can be acquired through different means, student, and this energy is required to do the work. So capability of doing work, an object having a capability to do work is said to possess energy. All I am saying is an object which is capable of doing work has got energy, has energy, students, has energy. Unless energy is there, work cannot be done. So that means the type of energies we are talking, energy can be transferred from one to another, students. There can be transfer of energy. Transfer of energy, student. So one object, student, it has more energy, and supposing this hits it. This object hits this object, what happens? Is an object which is having energy, high energy, you are saying it hits it, it will displace the object through a distance s. What happens, students? This object is displaced. The object is displaced from initial position to the final position. So that means work has been done, student. Work is done when work is force into distance. Force into distance, you have studied work. So force is applied, displacement takes place. So the object has done work, but for doing work, the object was having energy. If it doesn't have energy, how it will do work? No. So the energy possessed by an object or the capacity of doing work is what we call as energy. Then what will be the units of energy, students? They will be same as the work unit joules, energy units also joules. So 1 joule of work done means you will need 1 joule of energy. ठीक है? If you want to do 1 joule of work, then at least you will need 1 joule of energy, students. You will need 1 joule of energy. And sometimes we use kilojoules. Kilojoule is 1000 joules, or it is written like 10 power 3 joules. Kilo means 10 power 3. So these are some of the things we already know, students. You all know about this, what we talked just now. Tell me, do you know or you don't know what we talked? All right, students. Let us proceed further. Energy, very good topic, very good topic. Therefore, students, energy possessed by an object is measured in terms of the capacity of doing the work. The unit of energy is the same as that of the work, joule. So, joule is the energy required to do 1 joule of work. And if you need larger unit, that we call as kilojoules. Okay? Now it is clear. The definition of energy is clear, students. Capacity of doing the work. How much capacity you have to do the work? That is our energy. And the units of energy are same as the work, students. Joules. And bigger unit is, you are saying, kilojoules. 1 kilojoule is equal to 10 power 3 joules. You are aware of the Joule was a scientist, student, British scientist. This is the picture of the Joule. Will see a lot of experiments by Joule in science books. He did his research in electricity, thermodynamics, and formulated laws for heating effect of electric current. And he experimentally verified the law of conservation of energy, that total energy is conserved, but it can transform from one form to another, student. The unit of energy and work is named up to honor the great scientist Joule. ठीक है? Up to now, everything is known to you. Everything is known to you. ठीक है? Can I proceed further, or you want to comment anything? You want to say anything about the energy? You have the energy or not, student? Tell me, do you have energy? If you
Yes,
don't have,
sir.
if you don't have energy, then what work you will do? Nothing. And I am always saying, "Arey, in our class, you are interacting with me. It is a live interaction class. Every person listens to you, to me in the YouTube. You can share it with your friends. They are listening to you. If you don't have energy, what interaction you will do with me? Nothing. So I say, oh, interact with me, have energy, because energy is also required to understand the science, student. If I don't have energy, my mind will go to sleep and I will not listen anything, or I am not understanding anything. So lecture is over. I don't know what was the lecture. Our lecture is like your movie is a story. What I am telling you is a story, student. And our story is not that you are the audience. Our story is you are also a part of the story which we are doing here. Interact, talk, ask questions, students, and learn what we are talking about. So that our picture becomes good. What we are shooting is also a Bollywood movie. Every time you are having a movie with me, and your interaction is important. How much we learn is important. I try my best so that you can learn and understand what we are talking energy. Can I work without energy? No. But when I say energy, it's the capacity of doing the work. And the units of the energy will be same as the work. And those scientists who worked their life on this, we honor them like James Prescott Joule, 1818 to 1889. See, he was working on this. Next. Okay, students, now the we are coming to, I said there are different types or forms of the energy, students. What are the various forms of the energy? What are the various forms of energy, student? Okay, what are the various forms of energy? In general, student, various forms of energy. Various forms of energy, students. What type of forms of energy you are aware of? Usually we say mechanical energy, student. Mechanical energy consists of two things. One is called the kinetic energy, students, and second is called the potential energy. These are very common and most important forms of energy. Besides this, student, there are other heat energy. So many other forms are there. Chemical energy, electrical energy, you are all using different forms of energies. Light energy. Our main interest in this chapter is this mechanical energy. In this chapter, we will be learning mainly two most important mechanical energy, student. One is the kinetic energy and second is the potential energy. Okay, satisfied? You want to learn more about this? You can read it. Read it, no problem. I already have a video on this with another student. She was a student of a sixth class international school. You can see what type of energy forms are there, students. You also have nuclear energy, which we told you, nuclear energy, the atomic energy, which is coming from the nucleus. So our interest will be to study these two types of energy, student. Now I am talking of kinetic energy, students. Kinetic energy. Can you tell me, students, what is the kinetic energy? You must have heard about it. You know about it. What you know about it? What is a kinetic energy? Kinetic energy is due to what? Tell me. Kinetic energy is due to what? Kinetic. Kinetic means due to motion, due to motion of the object, student. Any objects which is moving, student. Any object which is moving, student, we say it has a kinetic energy. Tell me yes or no.
Yes, sir.
A car is moving, bicycle, motorbikes, you are moving, student, you are running. An object starts moving, this object starts moving, student, moving. It is moving. Then what we say? Any moving object, any moving object has kinetic energy, student, kinetic energy. Athlete is running, water is flowing, a flying aircraft, students, on the everything, wind is blowing. They are all examples of kinetic energy. You are just speeding car, bicycling, if you are bicycling, students. What is happening? You are in motion, student, all the things. So what is happening? Now, the question is, what are the factors on which kinetic energy will depend, students? What are the factors on which kinetic energy depends? I said there is a kinetic energy. It means it has a capacity to do the work. Yes or no? Tell me. What is it said? Energy is a ability to do the work, capacity to do the work. If kinetic energy is there, then body has a capacity to do the work. Yes or no? Tell me. It has capacity to do the work. Tell me yes or no. I supposing here is an object, student. Here is an object. It is at position A, student, at position A. Here some object, moving object, supposing if this is a heavy object, supposing, ठीक है, supposing there is a moving object like trolley, it hits it, it hits it. What will happen? It will move from its original position. The object will be displaced. Tell me yes or no. There will be displacement as supposing in the object, student. The trolley was having what? Kinetic energy. It was having kinetic energy because it was moving. It is in motion. So this has hit it, this object, and the object moves. Object moves from point A to point B, students. Object moves from point A to point B. There is a displacement which has taken place. That means the work has been done. Work has been done on the object by moving trolley. Yes or no? Tell me. How much work has been done? Force into distance. This trolley was having a force, applied a force, trolley applied a force on this object and it was displaced by a distance s. And the work done can be calculated by this formula. If you tell me how much force is there, then how much displacement is there, we can calculate the work. So students, you are saying, what you are saying, students, that the trolley was having kinetic energy. Tell me, was having kinetic energy? Yes or no? Answer. Because it is in motion, moving object has kinetic energy. Yes or no? It hits it, it moves.
Yes, sir.
Supposing the moving object, what the moving object have you learned the motion chapter? In motion, you learned, student, moving object has velocity. If the velocity increases, students, what will happen? If the velocity of the trolley increases, then what will happen? The object will go greater displacement. That displacement will become more. That's what I'm saying. If this has less velocity, if it is moving with a less velocity, the displacement will be less. If velocity is increased, the displacement will be more. Yes or no? Then more work will be done. S will increase. If I increase the velocity, then you are saying the box will move more further away. Thus, as this S2 now, this is my S1 displacement, this is my S2 is larger. If velocity is increased, more displacement. Therefore, kinetic energy, which is doing work here, increased. That means the kinetic energy, student, depending on the velocity of the object, velocity of the trolley. With increase in velocity, students, the work done increased. Work done increased. with increase in velocity. Therefore, we can say that the kinetic energy depends on the velocity. Kinetic energy increases with increase in velocity. How much it increases, that we will find out by a formula. By a formula. Second thing, what I do, student. First thing, what I did. This one. Second thing, what I do, student. Here I have increased the velocity. Second, I increase the mass of the trolley. Mass of the trolley, student. What happens now? If this trolley which is hitting it, supposing it was 100 kg. Now I make the mass of the trolley 200 kg, student. Then it hits it. Tell me, will the displacement increase or not increase for the object? Tell me what will happen to the displacement of the object now, students? If I increase the mass of the trolley, what will happen to the displacement? It will increase. Tell me. Therefore, students, if if I increase the mass of the trolley and hits it, it will go farther away. Displacement will increase. That means work done will also increase. The work done by the trolley on this box which we have kept here increases if I increase the velocity. It also increases if I increase the mass of the trolley. Therefore, we can say, student, the kinetic energy depends on two factors. What are the two factors on which kinetic energy depends, students? Tell me, what factors are there? I can say that, students, that the kinetic energy depends on one, mass, and second, velocity. Yes or no, tell me.
Yes, sir.
Okay. Therefore, kinetic energy has the capability to do the work. Here the work which we were talking were moving the object from one position to another position. The displacement we are measuring. If I increase the mass, displacement increases. If I increase the velocity, displacement increases. Therefore, we said kinetic energy is dependent on the mass as well as the velocity, students. So we have to then derive the formula for this kinetic energy. How will we derive the formula of kinetic energy, student? Formula of kinetic energy. So what you are saying, student, kinetic energy is due to motion of the objects. When object starts moving, they have the kinetic energy. Supposing supposing there is an object which is at rest, student. What is the initial velocity here when it is at rest? Initial velocity is, what is the initial velocity for a body at rest? Tell me. 0. Now it starts moving. This starts moving. ठीक है? When the object starts moving, student, supposing it goes from point A to point B. It goes from point A to point B. So this is the displacement S. This is the displacement is S. So when object will move, students, it moved from U, and when it started moving, it will have a velocity V. V is the velocity when the object starts moving. ठीक है? So the initial velocity is U, final velocity is V, student, and it will have some acceleration. Supposing A is the acceleration of the object. A is the acceleration of this object, students. Then in the chapter of the motion, what we studied? There is a relationship between acceleration produced and the distance covered, student. What is that relationship we studied? V square V square minus U square is equal to 2as. Did you study this Newton's law of motion? Tell me. V square minus U square is equal to 2s. Did we study this? Yes or no? So if we want to find the displacement, student, what will be the value of the displacement? The value of displacement will be what, student? V square minus U square by 2a. This will be my displacement. Divide by 2a, I will get the displacement, student. So this is my displacement, which is S is equal to V square minus U square by 2as. This is the equations of the motion which we studied, student. So the object will, what will happen when the velocity changes, student? Acceleration is produced. And what has the result of this? If, why will the object move, student? Why will the object move? Tell me. The object will only move. You are saying this is an object. Only if you apply a force, student, it will move. Am I right or wrong? Without a force, it will move? No. When you apply a force F, it moved from point A to point B. Okay? Got my point? You have applied a force on this A, student. It was at rest. U initial velocity 0 and final velocity, you are saying, student, is V. Final velocity is V. And you are saying the uniform acceleration produced in the object is, student, A. Okay? So what will be the displacement in the object, which I am saying S? This distance, student, this distance, how much? S is the displacement. So student, what you know, V square minus U square is equal to 2as. Therefore, I can calculate from here, student, the displacement S is equal to V square minus U square by 2a. This is the displacement suffered by the object. Displacement of the object. When a force F is applied. Is it okay? Clear? Tell me. And you
Yes,
know
sir.
what is the formula? Force is mass into acceleration, students. Force is mass into acceleration. Second law of motion. We studied that in the chapter of motion. Yes or no? Then what is the work done, student? What is the work done when object moves from point A to point B? Work done is force into displacement, students. And what is the force here? M. If M is the mass of the object, M, what is M, student? M is the mass of the object. M is the mass of the object. Then force is mass into acceleration into displacement. Displacement is S. What is the value of S? We have calculated the value of S here. This is our S value. S value, equation 1. So put S from 1, from equation 1, this one. So what will we get? Ma into V square minus U square by 2a. A will get cancelled, student. So what is the work done then? M V square minus U square by 2. U is a 0, initial velocity is 0 because the body started from rest. U is 0, then what is this? Half mv square. So the work done is equal to half mv square. The work is done is equal to the work done is equal to change in kinetic energy of the object of the object. This is equal to change in kinetic energy of the object. So this is nothing but student kinetic energy. So this is the formula of the kinetic energy, student. Half mv square. So we have derived the formula of the kinetic energy, student. Therefore, kinetic energy of any object, any moving object is equal to half mv square. So this is the derivation, student. Question was asked in the paper. Derive the formula of kinetic energy. Can you do it, student? Tell me. You will be able to do it? Formula of kinetic energy? Any doubt?
No, sir.
You have
No,
noted
sir.
everything?
Yes, sir.
What are the units of the kinetic energy? Same as the work, which is joules. Units, SI units, student. What SI unit of energy we are using? SI units, joules. Therefore, students, we say that kinetic energy is directly proportional to mass of the object and is directly proportional to square of the velocity. Kinetic energy is directly proportional to mass and is also proportional to square of the velocity, students. If the object velocity is increased by 2 times, the kinetic energy will become to the square 4 times. It will increase by 4 times, student. Is it clear? That kinetic energy is proportional to mass is also proportional to v the square. Proportionality constant is half here. This is my proportionality constant. Okay? If I increase the velocity 3 times, the kinetic energy will become 9 times. 3 the square is 9. Got it? Clear?
Yes, sir.
Okay, very good. Here is a numerical, then numerical, numerical, you do it so fast, student, on kinetic energy. Question 1 on the screen. Question 1 on the screen. An object of mass 15 kg is moving with a uniform velocity of 4 meter per second. Student, what is the kinetic energy of the object? Question is on the screen, students. You have 1 to 2 minutes to answer this question. Okay, you are brilliant, students. You have understood the formula of kinetic energy. Apply the formula. Apply the formula, students.
Sir, it is 120 joules.
Correct answer. So fast. You are so, I mean, you're able to do so fast. I can't do so fast, students. I mean, your brain is so sharp, better than me. Kinetic energy is half mv square. Half. What is the mass, student? Units we have to be careful. Units we have to be careful. 15 kg. Velocity is how much? 4 meter per second square students. So how much you are getting? 4 16 8 120 120. And what are the units? Kilogram meter square second minus 2. This is nothing but 120 joules. Okay? You should always write the units, student. You will lose the marks otherwise. Next question on the screen, students. What is the work to be done to increase the velocity of a car from 30 km per hour to 60 km per hour if the mass of the car is 1500 kg, students? Question, you have 1 to 2 minutes to answer the question, students. What is happening? Car is going on, student. You are as a car student. So what is the result of this? Your car is moving. Student, they are driving a car. Then what is happening? The car is moving. What is the work done to be done to increase the velocity of a car from initial velocity is 30 kilometer per hour and second velocity is how much? 60 kilometer per hour, students. Mass of the car is same for both the cases. 1500 kg, students. So how much work will be done? So how much work will be done, students? The work is done due to what? Kinetic energy. So what is will be the first, you have to see the units are kilometer per hour, student. You have to convert this into meter per second because SI units 30 into 1000, 60 into 60, students. Okay. This is meters per second. Here also you will do the same conversion. 60 into 1000, student. 60 into 60 meter per second. Okay, what is the values, students? Here you have to calculate. In both the cases. And find the kinetic energy 1 half m u1 the square. Find the kinetic energy 2 half m u2 the square and find the work done will be equal to change in kinetic energy. Change in kinetic energy, students. What will be that? E kinetic energy 2 minus E kinetic energy 1. So find out this value, which is the work done. Change in kinetic energy. Kinetic energy 2 minus kinetic energy 1. Find this value, students. What is your answer, students? Anybody got the answer?
No, sir.
Okay, then this is a homework. You will do it and it involves some calculation for you. We will get your answer in the next class. So this was the second lecture on work and energy, students, where we know what is kinetic energy, how do we calculate the values of kinetic energy, and how to solve numericals on the kinetic energy, students. Okay, thank you very much. Then we will meet you in our next class for further lecture on work and energy, students. Thank you very much for answering questions. Stay alive, stay active, have energy, and let us learn the ninth class science completely, students. And you can score 100 out of 100. Okay, then. Bye bye. We'll meet you in the next class.
Thank you, sir.
Okay.